Hi everyone, in today's video we are going to be introducing rigid motions. First, let's discuss the difference between preimage and image. The preimage is the original figure before the transformation has been performed. That's represented by triangle ABC. Notice in the diagram it has it labeled preimage, and I always put a 1 where my preimage is. The image is a new figure created after the transformation has been performed, and it's represented by triangle A prime, B prime, C prime. Those apostrophes we call prime. And I always put a 2 where my image is. 1 represents what happens first after the transformation is the second, which is the image. Next, we have what is a transformation. A transformation is a mathematical operation performed on a figure that changes its location or preimage. Remember, preimage is the first thing before the transformation has happened. Transformations are represented using capital letter and an arrow, for example. Here's the transformation, triangle ABC, after the transformation becomes triangle A prime, B prime, C prime. Let's talk about our first type of transformation, which is a translation. What is a translation? A translation moves every point in a figure over the same distance and in the same direction. Translations are described by their movement, such as 5 units to the right or left and 2 units up or down. Here we have an example. Triangle has vertices x, 0, 0, y, 3, 1, and z, 1, 3. Its image has vertices x prime, which is 3, 2. So let's graph this. Label it x prime. Y prime, which is 6, 3. And z prime, which is 4, 5. Draw the image and specify the translation. So take a moment right now, pause the video to decide what type of transformation is happening here. I'm going to look at x and then x prime. How am I getting from x to x prime? I'm going to the right, 1, 2, 3, and up, 1, 2. So we represent this by, on the x-axis, I'm going to the right by 3, so x plus 3, and up 2, which is y plus 2. You can also represent this as t, 3, 2. Notice a t for translation. So the triangle has been moved 3 units in the x direction and 2 units in the y direction, but its shape has not changed. I could do the same thing and go from z to z prime. I went over 1, 2, 3, up 1, 2. Same for y, over 1, 2, 3 to the right, up 1, 2. So the general rule is I am taking my x value, I'm either adding or subtracting some value, which we're going to call it a, or comma y plus or minus some value called b. Or we could just do capital T for translation, a comma b. Every point in the shape moves the same distance in the same direction, and the side lengths remain the same. So therefore, a translation is a rigid motion. Corresponding sides have the same length, and corresponding angles have the same measure. The images are congruent. Our next transformation we have is a reflection. What is a reflection? An object can be reflected across a line of reflection to produce an image. This can be the x-axis and y-axis. Each point in the image is the same distance from the line of reflection as the corresponding point of the preimage. The figures face in different directions. Because the figures are facing in different directions, the orientation has changed. Orientation means the order of lettering is different. So let's take a look at our diagram. We have triangle ABC, which I'm going to put a 1. That's my pre-image. And triangle A prime, B prime, C prime is my image. I'm going to put a 2. So the ordering of the letter is different because I'm going ABC, which is going clockwise. A prime, B prime, C prime is going in the opposite direction, which is counterclockwise. We know that this is a reflection because the orientation has changed. The direction of the letters is different. So let's take a look. It asks, what is the coordinate of B prime? B prime is right here, so that's 3, 5. B to start off with was -3, 5. Because the image is a reflection, B prime is the same distance from the y-axis as B, which is 3 units. Notice here we have 3 units from the y-axis, 3 units to the y-axis to B prime. The general rule for reflection in the y-axis is -x, y. Or we rewrite this as little r with the subscript of y-axis. So that means reflection in the y-axis. Lastly, a rotation is a rigid motion because the corresponding sides have the same length and the corresponding angles have the same measure. The images are congruent. They don't change shape or size. Our next transformation is rotation. What is a rotation? A rotation moves a figure around the center of rotation by a given angle. Every rotation has a center of rotation. A positive angle rotates the figure counterclockwise direction, and a negative angle rotates it in a clockwise direction. How does the distance from C to the origin, here's the origin, compare to the distance from C prime to the origin? That distance is the same. The distance between the point on the object and the center of rotation is the same as the distance between the corresponding point on the image and the center. Notice for this one we have a capital R, that means rotation, of 60 degrees. Triangle ABC is rotated 60 degrees about the origin. The most common rotations are a rotation of 90, 180, and 270, which we've talked about previously. Capital R's are rotations, lowercase r's are reflections. A rotation is a rigid motion. Corresponding sides have the same length, and corresponding angles have the same measure. The two triangles are congruent. They have the same sides and the same angles. Our last transformation is a dilation. A dilation of an object changes the sides of the figure, but not its shape. So this one is different than the previous ones we've discussed because it does change the size. Corresponding angles have the same measure, but corresponding sides do not have the same length. Therefore, a dilation is not a rigid motion because it changes the sides of the lengths of the sides of each figure. So notice my examples here. I have this small rectangle. That's going to be the preimage. I'll label it with a 1. And then the big green rectangle is our image. We'll label with a 2. That is being dilated by 2. It's doubling in its size. And when we think of dilation, we think of multiplication. So we're going to multiply 2 by the x and y values. Whereas if we look at the next picture, I have quadrilateral ABCD. That's going to be my preimage, and my image A prime, B prime, C prime, D prime. Notice that this is getting smaller, so it's a dilation of 1/2. We're multiplying 1/2 by the x value and the y value. So in a dilation, the image is either bigger or smaller. And remember, it is not a rigid motion.